Hello everyone, welcome to today's lecture. In this lecture we are going to discuss about control memory. So we all know that computer has mainly three components: CPU, IO devices and memory. And CPU is further divided into three components, which is and CPU also has three main components, which is ALU, registers and control unit. ALU is used to perform the arithmetic operations. Register is used to store the temporary data, and the control unit is used to generate the control signals. And we all know that if you want to perform some micro operations, at that time we required some control signals, and that control signals controls the flow of execution. So every instruction in the processor is implemented by a sequence of one or more sets of micro operations. Each micro operation is associated with a specific sets of control lines, which when activated cause that micro operation to take place. To execute an instruction, the control unit of the CPU must generate the required control signal in the proper sequence. So due to the signal, the execution of the program, the execution of the micro operation will be done. So there are two approaches used for generating the control signals in the proper sequence, as a hardware control unit and the microprogram control unit. So the first one is the hardwire control unit. So it is implemented with the help of gates, flip-flop, decoders, etc. in the hardware. So here the name hardwired because here we are using hardwares to implement this unit. So that is why the name hardwire control unit. The inputs to the control units are instruction register, flag, timing signals, etc. This organization can be very complicated if we have to make the control unit large. So if you want to build the large control unit, then this is a difficult approach, because here we are using many flip-flops, many decoders and so gates and so on. So that's why. So if the design has to be modified or changed, all the combinational circuits have to be modified, which is very difficult task. And in this big control unit, if we want to change anything, we want to update anything, at that time we have to update flip-flops, decoders, gates, etc. So this is a very difficult task. So this is hardware control is somehow difficult. In the hardware control, the control unit uses the fixed logic circuit to interpret instructions and generate the control signals from them. The fixed logic circuit uses the contents of the control step counter, content of the instruction register, content of the condition code flag, and external input signals such as interrupt request to generate the control signals. Here the fixed logic circuit block diagram is shown here. So this is the instruction register. So from this instruction register, the instruction is sent to the fixed logic circuit. Now instruction register has a three input, which is three parts, which is the address, opcode and the mode bit. So the decoder decodes that bit and send it to the fixed logic circuit. Now some external inputs and condition codes is also given to this logic circuit, and one counter is maintained, and on that we are providing some clock pulse. And after getting all this input, the fixed logic circuit generates the control signal, and this control signal is used to control the execution of the program. So this is all about the hardware control unit. So the advantage of hardware control unit is it is a fast, because control signals are generated by the combinational circuits, and we all know that now hardware control circuit is made up with the gates, flip-flops, decoders, etc. So that is why this is a very fast approach. The delay in the generation of the control signals depends upon the number of gates. It has a greater chip area efficiency since it uses less area on chip. So these are the advantage of hardware control. The disadvantage of hardware control unit is more the control signal required by CPU, more complex will be design of the control unit. So if you want to generate a large amount of control signals, at that time the system is very difficult. Modification in the control units is very difficult because we have to change each and every flip-flops, decoder, gates, etc. It is difficult to correct mistake in the original design or the adding a new feature in the existing design unit design of control unit. So this is all about the hardware control unit. Now the second approach is the microprogram control unit. So the microprogram control organization is implemented by using the programming approach. In the hardware control unit, we'll use the hardware to implement the control unit, while in the microprogrammed control unit, in the name program, so this is made up with the programming approach. In the microprogram control, the micro operations are performed by executing a program consisting of micro operations. A control unit whose binary control variable are stored in memory is called a microprogram control unit. A control word in control memory contains within its a micro instructions. So in the micro instruction, the control words are there, and the control words is in the control memory. So the micro instruction specifies one or more micro operations for the system. A sequence of micro instructions constitute a microprogram, and the control unit consists of control memory used to store the microprogram. So here the main part is the control memory. Now we are providing instruction to the control unit, and in that instruction multiple micro operations are there, and that all micro operations combined together generates a microprogram. And if you want to store that microprogram, at that time will require the control memory. So control memory is a permanent read-only memory. So this is a ROM. Yes, in our laptop there is one ROM, and in which we can only read the data. We cannot write anything on the RAM. Yes. So control memory is the read-only memory. The general configuration of the microprogram is shown in here, but before that we'll see that in the control memory, because once we defined the microprogram, and because this is a control, because it is the ROM memory, so that is why we can't change the microprogram once we saved it, once we add it. Yes. So this is the general configurations of microprogram control unit. So here here is the control memory. This is a read-only memory. Yes, in which the microprogram is stored. This is a control data register. So, and this is a control address register. So our instruction is stored into the memory, and it has a specific addresses. So in the control address register, the address of that instruction is stored, and in the control data registers, the instruction, suppose at the location 001, some instruction is stored. So 001 location is stored onto the control address register, and that 001 instruction micro operation that we have provided to the control unit, that is stored onto the control data register. So we can say that in the control data register the instruction is stored, while in the control address register the address of that instruction that is stored onto the memory is stored. Now when the process is start at that time, so from the control memory, first the address here, the address of the register in which the instruction is stored is fetched, then will perform, and then from control data from the control data register the instruction is fetched and will perform the micro operation by the control unit. And here the next address information is stored at the next address generator, which is called sequencer. So here next address generator means when the control unit performs the execution at, suppose control unit currently executing the instruction stored at the 001 location, so the next address is 002. So that is automatically calculated by the next address generator or the sequencer. Here we are providing some extra bit, here extra input to the extra bit to the next address generator, and based on that the next address of the instruction will be calculated, and now this address is given to the control address register. So from that address the data means instruction is fetched, and the control unit performs the desired micro operation. So this is how the microprogram control unit works. So the advantage of microprogram control unit, it simplifies the design of the control unit. Thus it is both cheaper and less error prone implement. Control functions are implemented in software rather than hardware. The design process is orderly and systematic. More flexible, can be changed to accommodate a new system specification or to correct the design error quickly and cheaply, because this is a program based. So in the program based, we can easily modify the program, we can easily detect the errors, we can easily modify the errors, we can easily correct the errors. Yes, complex functions such as floating point arithmetic can be realized efficiently. The disadvantages are a microprogram control unit is somewhat slower than the hardware control unit, because time is required to access the micro instruction from control memory, so it requires more time. The flexibility is achieved at some extra hardware cost due to the control memory and its access circularity. So this is all about the microprogrammed and the hardware control unit. So that's it. Thank you so much.